Everyone, in this presentation we'll see how to design a concrete mix for M45 grade, a high strength durable mix using fly ash as a mineral admixture and superplasticizer as a chemical admixture following IS 10262-2019 for the mix design procedure and IS 456-2000 for durability requirements. Before calculations begins, we need our design brief, the data that fixes our targets. This includes grade of concrete, workability requirements, type of cement, method of placing, maximum aggregate size, degree of quality control, exposure condition, and the type and grading of our aggregates. So for the concrete mix design, we are using IS 10262-2019 and IS 456-2000. For our given data, we are using OPC 53 grade cement with fly ash class F, replacing 30% of the cementitious material, and a PCE based superplasticizer at 1.2%. Specific gravities are 3.15 for cement, 2.20 for fly ash, 1.145 for the superplasticizer, 2.65 for coarse aggregate, and 2.60 for fine aggregate. We are designing for severe exposure with 20 mm maximum aggregate size, a required slump of 100 mm and zone 2 sand. Step 1 is calculation of target mean strength. For M40 grade and above, IS 10262 specifies a standard deviation of 5 newtons per millimeter square. So our target mean strength is 45 plus 1.65 times 5, which gives us 53.25 newtons per millimeter square. Step 2, water to cementitious material ratio. For severe exposure, IS 456 table 5 gives the maximum water cement ratio at 0.45. But our high target strength, and the benefit of fly ash combined with a superplasticizer for workability, we adopt a lower ratio of 0.35. So this is the water to cementitious material ratio, meaning water divided by the combined mass of cement and fly ash. Step 3, determination of water content. We start with the base water content of 186 kg per meter cube for 20 mm aggregate at 50 mm slump. Since our required slump is 100 mm, 50 mm higher, we add 3% for every 25 mm above the base, giving us a 6% increase. 186 times 1.06 equals 197.2 kg per meter cube. Because we are using a superplasticizer, we can apply up to a 20% reduction. So 197.2 times 0.20 gives 39.4, and subtracting that gives us a final water content of approximately 157.6 kg per meter cube. Next is calculation of cementitious material content. Total cementitious material equals water divided by the water cementitious ratio. 157.6 divided by 0.35 gives 450.3 kg per meter cube. Fly ash at 30% of that total comes to 135.1 kg, leaving 315.2 kg of OPC cement. We can check this against IS 456 minimum of 320 kg per meter cube for severe exposure. And since 450.3 exceeds that comfortably, it's okay. We can adopt the same. It's also right at the maximum cementitious limit of 450 kg, which is acceptable for a high grade mix using mineral admixture. Superplasticizer dosage at 1.2% of the cementitious content works out to be 5.4 kg per meter cube. Next step is calculation of coarse aggregate volume fraction. The base value for zone 2 sand and 20 mm aggregate at a water cement ratio of 0.5 is 0.62. Our adopted ratio is 0.35, so a difference of 0.15. Since the rules add 0.01 for every 0.05 difference, that is 3 increments, or we can say it is 0.03. So our coarse aggregate fraction becomes 0.62 plus 0.03 equaling 0.65, and fine aggregate takes the remainder 0.35. Step 6 is the calculation of mix based on absolute volume method. Starting with 1 meter cube of concrete, we subtract 2% for entrapped air with 20 mm aggregate, giving us 0.92 meter cube. We can then find the volume of each component. Cement volume is 315.2 divided by 3.15 times 1000, giving 0.1000 cubic meter. Fly ash is 135.1 divided by 2.2 times 1000, giving 0.0614. Water is 157.6 divided by 1000, giving 0.1576. Superplasticizer is 5.40 divided by 1.145 times 1000, giving 0.0047. Subtracting all of these from 0.98 gives 0.6563 meter cube for total aggregate. Splitting that aggregate volume, coarse aggregate is 0.6563 times 0.65, giving 0.4266 meter cube, which at a specific gravity of 2.65 gives a mass of 1130.5 kg per meter cube. Fine aggregate is 0.6563 times 0.35, giving 0.2297 cubic meter, which at 2.60 gives 597.2 kg per cubic meter. So here is our final mix per meter cube. 315.2 kilograms of cement, 135.1 kilograms of fly ash, 157.6 kilograms of water, 5.4 kilograms of superplasticizer, 597.2 kgs of fine aggregate, and 1130.5 kg of coarse aggregate with the water cement ratio of 0.35. Expressing this as a ratio by mass, cementitious material to fine aggregate to coarse aggregate, we get 1:1.33 is to 2.51. Within the cementitious material, cement and fly ash split roughly 70-30, and superplasticizer dosage remains at 1.2% of the cementitious content. Thank you.